Greetings, ladies and gentlemen. Welcome to our next lesson in the Big Ideas book, Lesson 4.5, page 174 for those of you who are in the 8 general class, and Lesson 13.5, page 598 if you are in the 7th accelerated group. We are going to continue graphing linear equations, and we're going to apply what we learned to graph equations written in standard form. Our essential question today: how can you describe the graph of the equation ax plus by equals c? And of course, I know that you are a person of character and intelligence. You've read the notes from the book for those corresponding lessons, and you know that the standard form of the equation is ax plus by equals c. Now, you may not understand it. You may not even understand most of the information that you read from the book. That's okay. You want to just get that idea so that when Mr. Ross talks to you, when I talk to you, that we make it understandable, that you start to get what we're doing here, and we move forward by asking questions in class. So, you know the standard form of a linear equation is ax plus by is equal to c, where a and b are not both 0. One of them can be 0, not both. Ladies and gentlemen, we can write any linear equation in standard form. All right, so when they're a linear equation, when you recognize linear equation, you can write it in standard form if you want to. And we know that we can graph a linear equation in standard form. We're just going to learn and practice how to do it today. And we have discussed that there are 3 ways. Well, we've discussed 2. We're learning the 3rd today. We've already discussed that we can make a function table of values, an xy function table. We've discussed graphing in slope-intercept form, y equals mx plus b. And now in standard form, we call it graphing using the x and y intercepts. So a quick review, doing it with the table of values, an x and y, where 4x minus 2y is equal to 6. If I make x 0, and then I do the math, negative 2y equals 6, divide by negative 2, I get negative 3. If I make x 1, I then need to subtract 4 from 6 and get 2, divide by a negative 2 and get negative 1. And if I make x negative 1, I'm now going to add 4 to 6 and get 10. And then when I divide by the negative 2, I get negative 5. Where I can then go to the graph, and I can graph these 3 ordered pairs, 0, negative 3, 1, negative 1, and negative 1, negative 5. And then, of course, I can draw my accurate, precise line using a straight edge, and voila. The other way we've looked at is putting it in slope-intercept form by subtracting 4x from both sides, saying negative 2y is equal to negative 4x plus 6, and then dividing by a negative 2, and writing y equals 2x minus 3, recognizing that our slope is 2. And of course, we understand slope. That means we're going to rise 2 and run 1, and that we have an intercept of negative 3. So we recognize our intercept as negative 3. We graph that point, and using our slope, we go up 2 over 1, up 2 over 1. And of course, we draw our precise line with a straight edge, recognizing we have 2 of the same points. Our y-intercept at negative 3 and our negative 1 point by using the slope. That's pretty nice. And the method we're going to talk about today is using the intercepts. So ladies and gentlemen, using that same equation, 4x minus 2y equals 6, we can talk about intercepts. We just have to remember, what does it mean to be an intercept, an x-intercept or a y-intercept? You should already have down y-intercept. And in just that case, what is the x-coordinate value when we are on the y-intercept, where it crosses the y-axis? That's right, we're at 0. So if x is 0, we can then solve for y by dividing by negative 2 in this particular case, and get that our y-intercept is negative 3. We already knew that from our other 2 methods that we just did. Now we want to talk about the x-intercept. The a, remember y-intercept is always b, so we want to talk about the x-intercept a. And of course, what would the y-coordinate value be if we're on the x-axis? Yeah, you got that one pretty quick too. We would also be at 0 for the y-coordinate. And so now you would have 4x equals 6. You would divide by 4, simplify, and you would get 3 halves. Okay? And then you would graph those 2 points, x are the y-intercept at -3 and the x-intercept at 3/2, which is 1.5. And so we have to kind of guess on that because we don't have such an accurate graph here. And then, of course, we have to believe in our math that we have 2 points, and so we draw our line. So if we take a look at our other graphs, it kind of looks like Mr. Ross didn't draw a very straight line, but I know if you look at yours, because you use a straight edge, you would see that your line does go through approximately approximately 1.5 and 0 at that ordered pair, the x-intercept. So let's do that a couple times, graphing in standard form using intercepts. So the first thing I'm going to do is make x 0. That means y is equal to -2. That was pretty straightforward. And then if I make y 0, well, heck, x is equal to -2. That one was pretty quick. And so I can put those 2 points at -2 and -2, and I can draw my accurate line, and voila, we're done with that one. All right? Using intercepts. Go to our next one. 3x minus 2y is equal to 2. Again, if I make x 0, I would divide 2 by -2, and I would get -1. If I make y 0, I would then get 3 divided by 2, which would be 2/3. So we can see that there are some issues with graphing with intercepts sometimes. We get these numbers that are not easy to graph on our graph, where we're guessing, we're estimating. Of course, we know where 0, -1 is, but then 2/3 on the x-axis, I'm going to guess is roughly there. And of course, my line, that was absolutely horrible. Yours would be better. We can verify, though, if you draw a nice straight line, you can verify because you can put this in slope-intercept form by subtracting 3x from both sides and get -2y is equal to -3x plus 2 dividing by a -2. And you would get that y is equal to 3/2 x minus 1. Well, we already had our intercept of -1. Our slope would be 3/2, which means we'd be going up 1, 2, 3, and over 1, 2. I was pretty close on that part, but if you had a straight line, you would see that that point would be right on the line. So using the intercepts is easy sometimes. It provides us with a problem in others, but we can still take that standard form of the equation and put it in slope-intercept form and graph that way. One more time, doing the intercepts, if my x is 0, my y would be 3. Dividing 6 by 2 would give me 3. And if I make my y 0, I would then be dividing 6 by a -2, and I would get -12. Well, -12 does not fit on my graph, so I'm not even going to go there and even try it because my graph isn't big enough. So I'm going to put it in slope-intercept form. 2y is equal to 1/2 x plus 6. Then dividing by 2, I would get that y equals 1/4 x plus 3. And of course, our slope would be 1/4, and our intercept would be 3. We knew that because of right here. And so at +3, I'm then going a slope of 1/4. We have to know what that means. It means going up 1 and over 1, 2, 3, 4. And I can't do a second up 1 and over 4, not big enough. So I'll go backwards, down 1 and back 4. And now I have those lines. And I can see that it would cross the x-axis somewhere back here at -12, 0. Other ways of graphing in standard form besides using the intercepts. Ladies and gentlemen, we're done with our first video. You have your quick write. I gave you a copy. You need to graph this linear equation in standard form. You can choose any method you want. And trust me, I'll be calling on some people to come up and show us what method you used when you did this quick write. Whether you're using the intercepts, did you make a table of values, or did you put it in slope-intercept form? Take a quick break, come back for video number 2.